Hey everyone, and welcome to this explainer. Consider this your ultimate student guide to computing. Today, we're diving straight into the foundational building blocks of Java programming. Now, if you've spent any time looking at Java, you know it can feel pretty dense. But today, we're going to uncover not just how this code is written, but exactly why it's structured this way. By the end of our time together, object-oriented programming won't just be a bunch of vocabulary words to memorize, it'll be a toolkit that you know exactly how to use.
Here is our quick roadmap for today. We'll start with number 1, what is a class? Then 2, variables and functions. 3, code to life, objects. 4, the object disguise. And finally, 5, wrappers in action. Let's jump right in.
What is a class? This is literally the foundation of Java.
If you're studying computing, you will constantly hear a class referred to in textbooks and lectures as a user-defined data type. But what does that actually mean for your code? It sounds like heavy academic jargon, right? But honestly, it's the absolute secret to Java's flexibility.
It makes a lot more sense when we contrast it with what we already know. Think about Java's 8 built-in primitive data types, things like int or char. Those are rigid. They hold a single, fixed value, and they have a fixed size. But a class? A class is a composite data type. It's composite because it holds an entire collection of values, and its size depends entirely on what you put inside it. It's tailored by you, the user, to fit your exact needs.
So, a really great way to think about your code is like a massive construction project. In this scenario, the class is the literal blueprint. It's a logical template that dictates exactly what properties, or state, and what behaviors the final structure is going to have. If you want to implement any real-world concept in a Java program, say a bank account, a student record, or even a video game character, it absolutely must be encapsulated within a class first.
Moving on to Section 2, variables and functions. Let's take a look inside that blueprint. A class basically boils down to two main macroscopic components, variables and functions. Now, variables define the state of our object, but Java gives us two very distinct types of variables to work with. First, we have instance variables. Every single time you create a new object, the Java compiler assigns a separate, unique block of memory just for its instance variables. But then we have static variables, which are sometimes called class variables. For these, there is only one shared copy for the entire class. That means all objects created from that class share that exact same variable in memory.
To put that into perspective, imagine a fixed deposit banking program with 3 distinct objects representing 3 different accounts. Each account needs its own unique balance, right? So they each maintain unique instance amounts, say 30,000, 20,000, and 50,000. But they all share the exact same interest rate of 8.5. Java only creates one usable copy of that 8.5 static rate in memory, and all 3 objects just share it. It's super efficient.
Now, alongside variables, we have functions. If variables are the state, functions define the active behavior of the object. A function is simply a block of code designed to perform a particular task, and it's split into 2 main parts. First, the header. This acts as the prototype. It contains the access specifier, the return type, the name of the function, and any parameters it might need to do its job. Then you have the body. This is enclosed in curly braces and contains the actual programming statements that execute when the function is called.
Section 3, code to life, objects. Time to create some instances.
We've got our blueprint and our components, so let's bring it all to life. If a class is just a theoretical blueprint, an object is the actual physical house built from it. An object is an instance of a class. It's a usable copy that holds real data in those memory blocks you just meticulously designed. When you create an object, you are finally giving life to that user-defined data type.
Creating this object in Java takes 2 distinct steps. Step 1, you must declare a variable of the class data type. Just like you type int a, you type your class name followed by whatever you want to name your object. But actually, that alone doesn't create the object, it just creates a reference to it. Step 2 is where the magic happens. You have to use the new keyword. The new keyword is absolutely essential because it physically allocates the memory for the new object and initializes its variables using the class constructor. Normally, as computing students, we just combine these 2 steps into one single line of code for efficiency.
Once that object is successfully created and sitting in memory, we put it to work using the dot operator. By calling functions, like say a calc function to crunch the numbers and a disp function to display them, we can pass in specific amounts and time frames. Our abstract blueprint instantly processes the math and generates a real, calculable reality right in the terminal window.
That brings us to Section 4 of the Object Disguise. Let's talk about wrapper classes.
As you advance, you'll hit a slight roadblock. You see, Java is an object-oriented language, meaning almost everything exists in the form of classes and objects. But those basic primitive types we mentioned earlier, like int and char, well, they are not objects. This is where a wrapper class comes in. It basically acts as a clever disguise. It literally wraps around a primitive data type so it can be represented and manipulated exactly as if it were a full-fledged object.
For all 8 primitive types, Java thoughtfully provides a corresponding wrapper class. And the naming convention is incredibly straightforward. Usually, you're just capitalizing the name. So a simple lowercase byte becomes the byte class with a capital B. A double becomes double. The only 2 exceptions you really need to memorize are int, which fully spells out integer, and char, which expands to character.
What makes these wrappers so powerful are their incredibly rigid features. First off, all methods of a wrapper class are static. That means you don't even need to create an instance of the object to call them, you just use the class name directly. Second, they're totally unchangeable. Once you assign a value to a wrapper class instance, it is locked in forever. On top of that, they all conveniently reside in the java.lang package, and all the numeric wrappers are actually subclasses of a master number class.
Let's wrap up with Section 5, Wrappers in Action. Let's see these functions actually do some work. By utilizing wrapper classes, we instantly gain access to incredibly useful built-in utility functions that basic primitives just lack. For integers, you have parseInt, which can miraculously pull a mathematical number straight out of a simple string of text. For characters, you get amazing diagnostic tools like isLetter or isDigit, which lets you evaluate raw user inputs with just a single line of code.
Connecting all these ideas together, the results are pretty amazing. If you try to add the number 10 to a string value of 25, the program just glues them together to output 2510. Not very helpful. But if you use integer.parseInt first, it correctly does the math and outputs 35. And when you feed keystrokes into character wrapper functions, it effortlessly generates completely accurate true and false logic checks behind the scenes. The wrapper classes are doing all the heavy lifting for you.
So, as you push forward in your computing journey and start tackling much larger projects, I want you to consider this. If wrappers give basic text and raw numbers the functional superpowers of objects, how will you use them to construct more elegant, powerful, and efficient code? Mastering classes, objects, and wrappers is exactly what separates a beginner from a true Java programmer. Thank you so much for joining me in this explainer. Keep experimenting with your code, and I'll see you in the next one.